What do we say when the stream starts?
Try YouTube.
Yeah, those are all correct. Chat clip that. Okay. So yesterday, by which I mean Wednesday, because for me there's 3 days a week, Monday, Wednesday, and Friday, because I don't even count it as a day if I don't get to see your beautiful shiny faces, right? It's just like it's a day not worth living, right? So yesterday, which is Wednesday, we learned about list singular. And what's even more fun than a list? Well, what if you had a list of lists, right? Right? Okay, I didn't get a lot of feedback on that one, and that's okay. The thing that's going on right now is breakout. Has everyone broken out?
Yep.
Almost.
Almost? Okay. You broken out? Hell yeah. Okay. Anyways, what I'm thinking you're probably working on is you're probably done with bouncing the ball around. You're probably done with having the paddle moving across. And what might be happening now is weird things happen when the ball hits either the sides of the window or perhaps a brick. And that's the hard thing to do. So you're probably going to want to be using that squirrely little fellow right there, dw.getElementAt. And you're probably going to want to be looking at the ball and taking the four corners around the ball to see if it's incident on anything. I suspect that's what you want to be doing. You have example code that does something very close to that, or at least does that correctly on the sides of the graphics window. And then we bounced the two balls into each other, and it didn't really work that well, but you at least have seen something that doesn't work. So that's good, right? Problem set 5. I actually just posted problem set 5. Don't look at it. It is smaller than the other problem sets. There are 2 problems on it. And basically, what problem set 5 is it's the hard part of the next project. So the next project is Image Shop, and the hard part of Image Shop is image equalization, which is just like, it's like a ton of work. So it will take you probably most of the entire week. And so we're just starting you early on it a little bit. So problem set 5 is not really distinct from Image Shop, but there's like an intermediate checkpoint. So you can start on that whenever you want. Only 2 problems? Yeah, sure. There's only 2 problems. I don't know. Today, we're going to learn a little bit more about lists versus everything else. The slides I'm going to show you tease at an advanced topic in computer science, and I'm just going to let you know that in advance. Why are we teasing at the advanced topic in computer science? I thought there was something in Python that was brutally confusing if you didn't look at this advanced topic. This is one of the cases where I made a slight change to the CS1 curriculum that has been adopted by the other instructors, so we think this will help you. It's only about a year old, so this is a little less evidence-based than some of the other stuff I've shown you that should help you. The advanced topic is called ID. I'll point it out when we bring it up, but we're going to work on that today. And I'm going to introduce the term value versus reference. Historically, value versus reference is not taught in CS1. I believe it has to be taught in Python because Python is too squirrely. Okay, so most of this term, you have dealt with things like strings, floats, booleans, integers. I think that's about it, right? And all of those have something in common, which is that they have some specific value, a value that does not change. 7 is always 7. Now, this can get a little confusing when you say, well, what if I take x, or perhaps I, and I say, for I in range 20. Well, doesn't I take on a bunch of different values? Yes. But the distinction is that each one of those values itself is unchanging. 1 never changes. This is distinct from lists. At the end of last class, I told you lists are mutable. They can mutate. They can join the X-Men, right? And because lists can join the X-Men, some of the rules don't apply to them in the same way. So we now are going to have types of variables that are going to have a different style of behavior in the sense that they can change things somewhere else in the program. This is probably going to be confusing. It was very confusing to me when I started learning Python. I'm going to introduce ID, and I'm going to use ID at the command line because I find it easier to use it there than in VS Code. Should I just try and do this in VS Code? It would be a lot of print statements. I'm going to do it at the command line. Okay, so the way I typically do this, that's pretty small. I'll say what I'm doing. Okay, so we can see this using the built-in ID function. What does that mean? I'm going to start up Python. And when I start up Python, I can do a variety of things in here. Always the first thing we do, just to make sure it's working, is we print hello world. Okay, that's not too exciting. We can also take a look at 7, which is the preferred value I use for examples. It's helpful that it's prime, which comes up sometimes. We can also look at 8. We can also set x equal to 7. Okay, so we can do all of these things. I am now going to introduce ID. ID gets the social security number, basically, of a value, or of anything else in Python. It doesn't have to be a value. So I can ask for the ID of 7, and it's quite long, but it's not that long, right? What 117.60.872 represents is the address that 7 lives at in program memory. So somewhere in my computer, there exists the value 7, and all of the 7s live at the same place. And if I have a variable that is equal to 7, really that variable is just saying I am holding the thing at this address. And I can prove that to you because I have a variable x, and I can see that it lives at the same address. There's one other thing I can do to check this, which is I can say x is 7. Is a little stronger than double equals, and Python gets really freaked out when you start using it because you're not really supposed to be thinking about Python in this way. Now there's something else going on, which is I can set x equal to 8. When I set x equal to 8, the ID of x will change, and it will be the same as the ID of 8. It will now be the case that both x is double equals to 8 and x is 8, though I get a warning because I shouldn't be thinking about that. But it is also no longer the case that x is 7. That has changed. That's false. This makes sense, I think, intuitively. Right. But this does mean that no matter how many times you use 7 in your program, you're always using the same 7. There's a few other things that have IDs, and there's things that you wouldn't necessarily expect to have an ID. So we can create a string, such as hi world. That's not what I meant to do. And we can check the ID of s. If we create an additional string, what's the letter after s? It's t. st. These two values are equal to each other, but they are not the same thing. So every time we create a string, we get a new copy of that string. It lives in a different place. It's a different type of thing. So the numbers in strings are a little bit different, even though they appear to be the same. And we can verify this by asking where they live, and we can see that they live at different home addresses. Something else we might also see is that these home addresses are much larger than the home addresses of 7 and 8. That's because in Python, at least, I think like the first 100 numbers, so I think like -10 through +100, they get special like VIP seating at every concert, so they're easier to get to. So I think 10 has a low number, and probably some larger number doesn't. Let's see how high it gets. Okay, so at least 1,000 doesn't get into the VIP seating, right? And I'm not exactly sure where the changeover occurs. Is this confusing? Yes. The correct answer is yes. You were close. You went like this. It's actually like this. Okay. 2 thumbs way up for this being confusing. Okay. I think I already showed you this. We have introduced in this class now lists. Lists are extremely powerful. They're extremely useful. They were probably the correct way to solve Wordle. And they're going to be the correct way to solve later assignments. Certainly Image Shop, beginning with the next problem set. But there's some finicky things about them. So we had x equals 1, y equals 1, These things are the same. They have the same ID. I'm going to show both IDs on the same line. They'll be comma separated. It's the same. And is, by the way, is the same thing as, this is going to be extremely annoying. X is y is equal to ID x double equals ID y. That's what is checks. It checks to see if they live at the same home address. It doesn't check to see if they're the same value. Okay, and this is true for 10 and 10. And it is not true for high and high. Oh, it is true for high and high. That's cool. Wait, I wonder why. Let's see. Oop. I think I have to create a high in a different line for it to be distinct. Okay, those ones are the same as well. Never mind. I have no idea how strings work. Don't ask me how strings work. I thought I figured out how strings worked. I'm wrong. Is this confusing?
Yes.
There you go. Yes. Okay, I got it. All right. Thank you. Yeah, see, you thought you understood. What's going on is depending on how close strings are declared to each other in Python, they're either the same or different. That's what's actually going on. Which is, it could be cooler, right? Like, that's maybe uncool, right? Let's do the example with lists. Okay, so we imagine we have some lists. So I'm going to say x is equal to the list that contains 1 and nothing else. That has some ID. X has some ID. I can look at x. I can look at the 0th element of x and see it as a 1. And I can check the ID of that 0. And that is the same 1 we know and love. But it got wrapped up with this other thing over here, right? So if, for example, maybe this is a present that we got, and maybe the present got lost in the mail or something, right? So I have a list that contains x. The list lives somewhere. And the list, I don't know, contains a highway that goes directly to x to 1's house or something like that. I don't know, or a portal. Maybe there's like a wardrobe that if you open it up, it goes to like a magical land or something like that. Okay, let's create another list that contains only 1. We'll call it y. And we can check a few things about y. I think x is equal to y. And that would make sense. Nope. X and y look the same to us, right? They are both a list that only contains 1, so it makes sense that they are equal, double equals. Is x the same thing as y? No. And now I can actually show you why this matters. Because one of the things I can do to x, because it's a list, is I can put more stuff inside that list. It's just like my grocery list, which I keep adding to, right? So I can say x dot, how do I add something to a list? It's not quite plus equals, is it? Okay, that worked. So we add a 2 to the end of the list. And now we can look at x, and we can look at y. And we can say that x is y. These are distinct because they have different IDs, they live at different addresses. And you would think it's always just like that, and then suddenly it won't be. Let me show you the weird thing that can happen. So I can create an A that equals to the list containing 7, and say, I need another list that contains 7, but fortunately I have one already. I have A, I can just use that. So I say B is equal to A. What is A? What is B? Is A equal to B? Of course it is. They are both the list that contains 7. I say I should add my next favorite prime number to the list, which I think is 11. Is 11 prime?
Yes.
Okay, thank you. So I'll say, I think I want to just keep A by itself, just containing 7, but I'm going to take B, and I'm going to add an 11 to it. Then I'll take a look at B, and this all seems great. This all seems really fine and normal. And then I'll say, I should go back and look at my list that only has 7 in it, because now I was going to use that as my list of favorite odd numbers. So let's go ahead and say we'll put a 9 in our list of favorite odd numbers. And then we'll look at A, and we'll look at B, and we'll see they were the same list the entire time. That is because A is B. The ID of A is the same as the ID of B. And the reason they have the same ID is because I used single equals assignment to set B to have the same home address as A. So sometimes, when you're working with a list, you're working with two variables that refer to the same list. And sometimes when you are working with perhaps a list that contains one, there might be two different lists that contain one described by different variables. Is this confusing?
Yeah.
Very good. I think you're understanding it because you think it's confusing. So there's a famous lecture on quantum physics. It's the first day of class in a quantum physics class. Have I told this anecdote before? And the professor walks in and says, well, unfortunately, at the beginning of the semester, I'm at a disadvantage because right now I'm the only person in the room that doesn't understand quantum physics. But my hope is that in 2 weeks, no one in this room will understand quantum physics, right? That's sort of teaching ID in Python. No one understands this stuff. And there's just like some extremely inane things you can do, like check the ID of the ID function. And check the ID of print, of course. You'll notice they're quite close to each other because they're both built-in functions. They're only about one block apart, right?
Neighbors.
Yeah, we can see how friendly people are. Like, are these closer friends than those? Oh, that's pretty interesting, right? Yeah, so ID is much closer to print than type is. Why wouldn't it be? Print and ID both look at the thing that you have and then show it to you. Type has to check what kind of thing it is. So, those are dramatically more complicated. And you can tell because type is a class and print is a built-in function and ID is a built-in function. So things that are next to each other are similar, right? Does it make sense what is similar? No, maybe sometimes, maybe not really, right? A lot of these are just design decisions. But the important thing, I think, is that everything is really far from one. Like, that stuff is super far apart, right? Actually, where's type live? Let's see. I didn't even check. Okay, that's way up there. And then ID of 1. So those are close together. So type is actually closer to being a value than it is to being a function. Isn't that fun? Should I ask if we're having fun yet? I don't think I want to know, because what if we're not having fun? Okay. Sometimes changing one variable may change another. Whoops. I showed that. I want to show you something, I'll say generously, that everyone hates. Okay, so I can set A equal to the list containing 1. I'm going to set B equal to the list containing A. Then I can look at A, and I can look at B. Now I'm going to set the, so I can change, for example, A0 to B7. And then I can look at A and B. There's other things I can put inside of lists. One of the things I can put inside of lists is a list. The type of B is a list, so that's something I can put inside the list A. So I can say A0 equals B, and then I can print A, and I have an infinitely recursive list that contains nothing. So that's pretty fun. So usually this isn't true, but that's something that is possible to do. I wonder if this is true. Oh, those ones are different. So actually, only every other one of the mutually recursive list that contains A is equal to A, even though they're both the same infinitely recursive list. So that's kind of fun. I'm pretty proud of this one. This was an example of something not to do at a Python talk I attended. So I just thought I'd show it to you. Don't do this, okay? Do you have any questions about why you shouldn't do this, or is it self-evident that that's horrible? It's very funny, though. Okay. Here's, man, so, like, you really get to have fun sometimes when you're a computer scientist. And my favorite thing to do is embiggening. I just love to embiggen things. Some people say that the actual way to do that in English is you're supposed to say enlarge, but I've never enlarged anything. I've only embiggened things, and I had great fun doing it. So let me show you an example of how we can embiggen something. At various points in time this term, you've probably tried to keep track of something like the current row in a Wordle game. And historically, we've actually had to do that by having a variable that is like outside of the function. That's like, and then you're always like, hey, why can that function see that variable name? It's because there's no rules, because Python makes everything up as it goes along. But let me show you one straightforward example. And I'm not going to cheat, because I'm not going to do this in a Python file. I'm going to do everything in the terminal, so that you know there's no funny business going on. In fact, I'm going to restart my terminal so you know that I haven't done anything sketchy. I'll clear it. Okay, so what am I going to do here? Well, let's set x equal to the list containing 0. And the list containing 0 is going to be perhaps the number of guesses so far in our Wordle game. I'm going to create a function, and that function is going to be called embiggen, which is one of my favorite verbs. And within embiggen, I'm going to take x0, and I'm going to set it equal to, and what is x0? x0 is the 0th value in the list x, so it is that 0 itself. So its address is 0 and its value is 0 right now. And I'm going to take it equal to x0 plus 1. And I think maybe it's easier to just do this. I think that's probably allowed, right? I can take a look at x, and then I can embiggen. Oops, I didn't actually call embiggen. But you can see where it lives. We can check the ID of embiggen. Oh, it lives somewhere, right? I'm going to try to embiggen. And I'm going to take a look at x. Then I'm going to embiggen again, and I'm going to take a look at x. And is this not just great fun? Like, we can now make things larger. We weren't able to make things larger until now, right? So now we can make things like balloon animals or the Eisenhower Interstate Highway System, both of which are large, right? There was a large number of balloon animals dancing to the Hokey Pokey outside of my apartment 2 days ago. It was very exciting. That's actually a true story. You can see it on the news. Okay, so sometimes this works and sometimes this doesn't work. But let me show you an example of something that doesn't work. So say instead of using x, I want to use y. And I'm just going to set y equal to 0, right? And I need to create a new function, so I'm going to call this embiggenify, so that we know it's different. And I'm going to say, well, let's take y, and let's just increase the value of y. We would probably expect this to work the same way, because after all, we were just able to make something else larger. So we'll go ahead and do that. So let's take a look at y. Let's check the ID of embiggenify. Let's look at embiggenify and see that it's a function. It is. It's the function embiggenify. Okay, now I'm just going to embiggenify real quick, and I bet absolutely nothing will go wrong. Oh my gosh! I'm not allowed to refer to that y. But okay, hear me out. Did I not just say, okay, there's a y here, and then I refer to the y inside a function? Is that not the exact same thing I did with x? It is. So this is just a language inconsistency. Lists are just different than other things. They're just silly. They're silly geese. And I think this comes down to mutability, but I've actually never had anyone explain to me why this is allowed. So anyways, have fun with that. Okay. Remember so why did I show you Haskell at the beginning of the day today, right? You still like Python more than Haskell, right? So we still like Python. Okay, so we still like Python. There's just like a little bit of roughness around the edges, right? And the edge specifically occurs when you have a list, okay? But the problem is Python lists are awesome. Okay, here's something else we can do. We got x. Sometimes you want a copy of x. So maybe you want z equals to x. But you don't want these things to be the same, and these are the same right now, right? This is much more interesting. Remember last time I had the Cook partisan voter index? It was a huge list, many entries. Right? I don't really want to copy that again. But not too bad. I can just set z equal to x, and I can take a slice. Remember slices? For example, I take the, up to the 5th element, something like this. Or I take everything after the 3rd element. Or I take the elements backwards. Well, I can just take the exact elements x has in the same order that x has them. And I can get a z that looks the same as x, but z is not x. I got a new ID for z and x. So this right here is how I make copies of lists when I don't want them to be the same. There is a catch here. I'm going to create an L1 that contains A, B, and C. I'm going to create an L2 that contains, I'm going to do the strings 1, 2, and 3. I'm going to set x to be equal to the list of L1 and L2. Okay. There's x. I think this makes enough sense. And I can look at L1 and I can look at L2. If I set z equal to x, z contains the same things. If I add something to z, such as x, y, I don't want to use those letters. Smiley, frowny, meh. Do you call this the, what is this face called? I like that you were all non-committal about what that face is called. That was actually really on point. So we can look at z. And the changes to z have also corresponded to changes of x. And I know what you're thinking. You're thinking, what if I want to keep my lists separate, right? No problem. You can make a copy and take y. Y has the same stuff in it. But if I pop off of y, I get the smiley back. Y looks a little bit different, and x and z look the same, right? Okay. X is z, right? So if I make some changes to z, they should correspond to changes to x. So we'll take z plus equal, I need another emoji. I will do heart. That I tried to do a heart. It didn't work very well. And I have to put that inside brackets to add it to a list. If I don't, here, I'll show you. Oh, maybe I can do that. It added the less than and the 3 separately, which is kind of goofy. And this will apply to z as well. But this did not apply to y, because y has a different ID. And I know what you're thinking. You're thinking, that means there's absolutely nothing you can do to y that will affect x and z, right? I heard that. I heard you thinking that, so I'm now going to address that concern. I'm going to go to the 0th element of y, and I'm going to go to the 0th element of that list, y, because I can look at this and see that as ABC. By the way, that is L1, which we created previously. L1, Y0. Okay? And I'm going to manipulate Y0. I'm going to take Y0. I'm going to take the 0th element, and I'm going to change it to a capital A. And so that is a capital A now in y. Now, nothing I do about y can change x and z, because the ID of y is different from the ID of x and z, right? So when I look at x now, that's definitely still going to be a lowercase a there, right? And it's not, right? And the reason it's not is because when I made a copy of x, it copied down the home addresses of the lists L1 and L2. And I can still manipulate the lists L1 and L2. Is this confusing? Yes. Correct. So what I actually have to do, if I do something like this, let's see, and I want a separate copy, I think you have to do something like x, I don't know. You have to write a for loop. Write a for loop. Okay. What am I doing? Function F11. There we go. Okay. That's copies. List methods. If you don't want to use x copy, you can say x.copy. These are identical. If you don't want to say x reverse, that's the reversal. You can say reversed of x. Oh, that's weird. What happens there? Well, you have to turn that back into a list. And that's why I always do this instead. Okay. We can append things to the end. I'm going to set x equal to just 789. X dot append, or let's take a look at x. X dot append 10. Something to note there. I would have thought, because of my background, that x dot append would return the list x with 10 appended onto it. That's not true. X dot append 11. The value this returns is none. Okay. Why is this confusing to me? Because all the time I write code that looks like this. I say y equals 7, and then I say y plus equals 8. And I'm used to changing the value of y. So I say y equals y times 2, right? I can't do that with append, because what I always want to do is I want to say, hey, x, this is x. I'm going to say x equals x dot append 42. And then I look up the third value of x, and x is none. This makes a lot of intuitive sense to me, but it's wrong. Don't do it. Don't use single equals with these list methods. How do you find out what you're doing every time? I would still be recommending that you're testing every single line of your code. So you write one line of code, and you probably, after you write this line of code, if you're in VS Code, do I have anything open? Thing? Perfect. What is going on here? So if you ever write x equals 1, 2, 3, you should print x. And then if you say x dot append 4, you should print x. And then if you say x equals x dot append 5, you should print x. And you should include all of those print statements so that when you make an error in the next line of code you write, and what's the next thing I would do, is I would say something like x1 equals 2, I don't know. That then, when you get that error, you're not surprised by what happens. We can also, append puts things at the end, which I think we can demonstrate. Oh, wow, see, that's weird. X is still defined as a variable, it's just set equal to none. You see how this could be confusing, right? Yeah, because if I put like that in there, it's like, oh, HJK is not defined. I'm like, well, that makes sense because I never defined HJK. But if you say HJK equals none, then you can like do that and like no error pops up. I don't know. Here's something I'm not supposed to show you, so don't watch this. You can delete variables and then you're not allowed to use them. Never do that. Okay, just it's gone. Okay, all right. So what else can we do? We can insert at certain locations. So I'm going to say x is going to equal, and what am I going to do here? I'm going to do something I know that I've shown you before. You can use lists to create empty lists, but you can also use lists to create lists from things that aren't already lists, such as a range. So this is a pretty easy way to get 10 values. I don't know what you kids are into these days, but in one of my other classes, everyone's always trying to use floating point numbers. Have you seen this? Everyone thinks there's numbers between 4 and 5. There's not. It's 4 to 5, right? There's only the integers, right? But there's all these people that are like, what happens if I divide 9 by 2, right? Well, you get 4, right? But everyone wants to think it's 4.5. Okay, so for the big 4.5 appreciators, do I have any 4.5 appreciators in this room? Yeah. Can I get a whoop whoop for 4.5? That's what I thought, right? So 4.5, great number, not a real number, right? Well, I mean, it is a real number. It's not a real integer. Yeah. Okay, so let's go ahead and, I think 4.5 deserves a place in my list x, right? So I'm going to insert 4.5. And I kind of want to insert it at the appropriate location, which is probably going to be like at position 5 or something. Ooh. what I do wrong, you do the location first, then the value. Okay, and this is in fact why you should do this example with floating point numbers. What am I even typing? Okay, x dot insert. I'm going to insert at position 5, I think, which is probably after the 5th element. Get it? After the 5th element? Right, 5th element, famous film, cinema?
I like how everything's orange in that movie.
Is everything orange?
Just a lot.
I associate it with orange, yeah. That's multipass, right? Okay, I don't know. 4.5. Where's this going to go? I don't know. Wow, I'm such a genius. I didn't actually think that was going to work. So we have welcomed 4.5 to our numbers, thanks to all of our the adoring, screaming fans of the number of 4.5, which is you all, right? So remember, if you start supporting 4.5, eventually it will find its place within the numbers. That's what insert does. What do we do to remove? Well, say you have a very mean professor who doesn't like 4.5, and then it's gone. It's gone forever. I'm sorry. It's just that 4.5 isn't a number. Okay. We can reverse things. Here's x. Here's x dot reverse. Wait, where'd x go? Did anyone see x? Does anyone know where x is? Oh, it was still there. I didn't see it right away. So when you reverse things, by the way, don't do this. This is against the rules, right? Okay, right? Why? Okay, I can make this much worse. Remember when I set x equal to list range 10? Okay, I'm just setting x up again. Okay, x is fine. We can x dot append a 10, no problem. Here's something that you definitely should not do, and you're all going to do it, by the way, because I've seen your code. A bunch of you are going to do this. And that's real weird.
I mean, you just told us not to do that.
So nobody doesn't have
Yeah.
That makes it even worse.
Yeah, this is real bad. Because this is actually a function I think I can apply to things. Okay, takes 0 arguments. Okay, no problem. Wait, I have a plan. That was allowed. Can I do it again? And anyways, I can't actually see the list it's reversing because I replaced the name of that list with the name of the function to reverse it, so I can never see that list again.
That's why you probably shouldn't do that.
Yeah, you should probably not do this. But, you can if you want to, if it's what you intend to do. So don't do that. Sort is awesome. Anyone have any favorite, so let's stick to numbers. Anyone have any favorite numbers? Just shout them out. I'll throw in 3.
96.
96, great number. Anyone have anything better than 96? 11, much better. Okay, anything worse than 96 and 11? Any bad numbers?
51.
51. I like that you're only giving positive integers, by the way. You're a classroom after my own heart. Okay, all right. Anyone else? 10. Okay. Anything?
0.
One of the numbers of all time. Right. Okay. Let's do like 1 or 2 more.
1. 2.
Okay. Here's x. Now, am I gonna do this? No. I'm gonna use y this time because I don't want to destroy my list. I worked very hard for this list. Actually, I'm just gonna make a copy. Another equals x. Okay. So here's x. Here's x dot sort. That's not what you meant to do, right? And here's another thing you didn't mean to do. X equals x dot sort. That's not what you meant to do either. Not to worry. I saved a copy. It's another. Okay, so we're going to set x equal to another. Okay. Let's do x dot sort. So we're doing the sort verb that is contained within the list x. This is a verb that belongs to a noun. And I'm going to put the parentheses at the end of it to denote that I'm doing the verb. So I'm not referring to the verb. I'm performing the verb. And then this will put your list in order. This is quite useful. You'll probably want to be sorting things more often over time as you get used to it. Yeah.
What does that do when the list isn't numbers?
So sometimes it works and sometimes it doesn't. So I think if I say x equals a, b, well, okay, we should start it's going to be fine with strings.
If it has both
Yeah.
numbers and letters.
So this is fine, right? And then, oh, I just realized there's no reason for me to check that because you have your own computer.
Oh. But what did everyone else do?
Everyone has their own computer.
That's tough.
Yeah. So it's if this thing works, right? That's all it's doing. It's just using that. And if you want to write a custom sort function, you can do that and look it up online on your own time, but it's not too bad. All right. Don't do this. Okay. I'm recommending you always use sorted. Here's x. Well, now I can't do sorted x. Okay. Do I have another? Okay, well that's already sorted. I'm going to put in my favorite list, which is, of course, 5, 3, 7, 2, 4, 6, 8. And if I sorted that, I get the sorted list back. Then I get to keep my original x. So I like sorted a lot, and I also like reversed a lot. Why does it return a list iterator? Wait, why didn't I just do this? There we go. That's a little bit better. So that's how I reverse my lists. I tend to be reversing lists all the time. I frequently put a bunch of things in a list and then realize I wanted them in the other way. Right. Okay. Last thing, this is an advanced topic. There's two things about Python I like, and this is like 1.5 of them. Do you remember the divisible by 6 or 7 homework at the beginning of the term? And I offered to give you 1 billion points of extra credit if you solved that in one line. This is the solution. It uses a list. So I'm going to write the function. We'll split it again. So I'm going to do something. Wow, why is that okay? There, that's not that bad. Okay. So I'm going to introduce the concept of a list comprehension. What is a list comprehension? It is a list where instead of writing down all of the elements, I describe what elements I want to have in my list. And I do this with a for loop. So, for example, if I want to have the first 10 even numbers, I simply say evens 2 times I for I in range 10. What is range 10? Well, we know what ranges look like, but we can look at the values in it. So if I take those values, then I say, well, for I in range 10, print 2 times I. That probably makes a certain amount of sense to us, right? Well, I can take that expression I put inside the loop and I can put it before the for statement. So I can say, print 2 times I for I in range 10. That one doesn't work. I'm not allowed to just write it all loosey-goosey out in the world like that. But if I slap some boxy braces around it, I get kind of what I want. And what do I get? I'm going to print out all of those values, but I'm also going to get a list back that contains the sort of values I created. And the thing is, print 2 times 1, any print value, let's see, hi. When I print, it creates a none. So y is equal to none, and I can check by looking at y. And in fact, if I put y inside a list, then I will see it as a none as well. So what I can do, instead of printing all of these, I can just say, well, why don't I just take 2 times I for I in range 10? And those are the even numbers, right? I think we did a slightly different example in class. We started at 40 and ended at 60, but actually we ended at 60 plus 1 because we wanted to include things. Okay. And what we were doing, I think, was not actually multiplying them by 2, but we were seeing if they were divisible by 6. Which isn't quite what I'm doing here. I'm seeing the remainder when they're divided by 6. But I don't only have to look at the remainder. I can check to see if the remainder is equal to 0. And that will give me some trues and some falses. That's getting a little bit hard to see, so let's structure this back into a print statement. I'm going to print the I value, and I'm going to print whether it's divisible by 6. This is probably looking a little bit more useful to us. You can see 42 is divisible by 6, 48 is divisible by 6, 54 is divisible by 6. And that's this, and that is what we have over here. So this is the same idea. This is not exactly what we want to be doing just yet, but we're getting there. We're getting a little bit closer. And at this point in time, this blew my mind. You can also put if statements inside these things. And only print in the case something is true. So Python's good again, is basically what I'm saying. Like, it was rough there for a while, but now it's good again. Okay. And I think on the divisible by 6 or 7 homework, it was something like this, but this isn't quite right, isn't it? Because I think you weren't supposed to have 42 in there because it's divisible by both 6 and 7. No problem. Instead of using logical OR there, what I really want to do is I just want to make sure these things aren't the same value. But when I do it that way, it's going to sort of, this inequality is going to break up these expressions. So I have to put them in parens, I think. So I'm going to check to see if it's divisible by 7. I'm going to check to see if it's divisible by 6. Each of those will either be true or false. And I want one of them to be true, but not both, so I just want them to not be equal to each other. And that's going to get rid of the 48. I actually don't need to print anything, do I? Or I don't need to print this. Okay. This isn't done yet. Because on divisible by 6 or 7, you also had to return something. You had to return how many values you printed. Not to worry, I have a plan. I printed 5 values, and I have a list of 5 nuns. So I can just put that inside a length. And that's starting to look pretty good, right? So I can define def div 6, 7, and I'm going to take a low value and a high value. We'll copy paste this. Oh no, okay. I'm going to return the length. I'm going to start at low and end at high plus 1. I'm going to take the rest of this code. Div 6, 7, 40, 60. How many? This will print them, and then I can see how many I printed. And that is the one-line solution to divisible by 6 or 7 that uses list, for, and if. And you already knew for and if today, and now you know lists. You are under no obligation to ever write a list comprehension ever in your life. They're sort of like this thing that can destroy your life if you get really fun into writing them. So look out for that. On December 1st, this thing is going to start called Advent of Code, where there's little programming assignments every day that you're supposed to post about on your LinkedIn and get hired. I did every single one of those last year in one line of code. And it's like, that's not like a healthy thing to do, right? But like, it was fun, and like having fun is healthy, right? And I think that's all I got for today. Does anyone have any questions about anything on Breakout? I can live code for 5 minutes, 6 minutes, and I can do whatever you want.
For the part where for the bouncing ball, there's like a thing where it's like a pause variable or like something, because you want it to only start.
Yeah. Let's see if I can get this back. Code. I'm going to grab this code from last class, and I hope it's going to work. So this is fine. So say I want to pause this in response to clicks. Right, so kind of crazy. What happens here is I have essentially a timer event that goes off all the time. I can just say if paused, return, and then it won't do anything. But somewhere I have to set pause to be true or false. So where I created all of my other variables down here, I'm also going to create something else. And I'm going to call it, I don't know, gw.paused. And that's going to start as false. Or no, it'll start as true. Because I'm calling that one gw.paused, I'm going to call this one gw.paused. The same way I put a box inside GW, I'm just going to put something called paused inside GW. And it's just going to be a Boolean. I'm going to add an event listener to, do I say click? Is click a click event? Okay. I'm going to call this the pause func. And this is only going to do one thing. I'm just going to grab this example. Let's see. This was other func. Okay. The pause is in time func, but I want to respond to the click event. Did I call it click? I called it pause func. Okay. Pause func. And pause func is only going to do one thing. It's going to set GW paused equal to not GW paused. So this will, or that's not how you do not in Python. I'm going to change paused from true to false every time I click. Okay, that didn't work. Wait, maybe it did. 0 positional arguments, but 1 was given. No problem. I need to put an E here. Okay. Okay, we're bouncing around. I click. When I click, what happens? GW paused changes to false. This changes to false. None of this code runs. The timer is still going. It's just when the timer clicks over, it instantly returns without doing anything. That's how I did it. There's other ways. That's probably the easiest. We've talked about it a little bit, some of the faculty, and I think that's probably the best solution. That didn't all fit on your screen, so I'm putting it in Discord so you can look at it. The important things are you're going to check to see if you're paused in a different place than you're going to change if you're paused. And you're going to have different event listeners for all of them. I think on Breakout you just click once and it changes it to be unpaused.